I will now present to you some of the topics I learned throughout this year, starting off with how I use critical thinking to analyze media, how I wrote an efficient research report using the proper formatting. After that, I will present to you on potential and kinetic energy and how unseen forces relate to the Olympic sport of shot put. After that, I will present to you on the color theory, and last of all, will reflect upon my 9th grade year. One of the most important topics we learned in humanities was how to analyze media. We learned to look at all the details, including text, imagery, and even the tone of the ad, to find the reality behind it. My thanks for loafing POL analysis is one example of how I analyze media. By using the figure of the young man in his casual stance, I was able to conclude that the targeted audience is lazy, able-bodied men. The medal being awarded is for loafing, as said in the text, which means that the young man is not doing his job. This is also symbolized by the cobwebs on the unused machinery. Hitler plays a role in this cartoon to specifically point out that the young man is not doing his job in the military area. This political cartoon has criticized citizens who are not participating or contributing to the war so that they will feel guilty and take up military activities. Once I mastered the skill of how to analyze, I was then able to contradict media and show the verity behind it. In my anti-propaganda, I first analyzed the flawless skin of the young lady and turned it into what an avid smoker's skin would look like after years of smoking. I then manipulated the text to contradict the false persuasion that smoking won't harm your appearance. Another major topic that we learned was how to properly write a research report. One of the main areas of growth was how to write a one-sentence thesis, since I always had trouble combining my ideas. I overcame this by taking unimportant details out of my thesis and at least listing the ideas in order. As you can see, represented by the underline and by the different lines, the ideas are listed one after the other. Another area of growth was writing commentary after each quote, since I usually just ignored it and continued with my essay. I made sure that each quote had commentary after it, even if it was one sentence. One example is the highlighted quote in yellow by Rachel Rawlins, and my analyzation in blue after it. In addition to learning how to analyze a quote, I also learned how to write a transition sentence at the end of the paragraph. My last sentence in paragraph 3 concludes its idea that Zimbabwe's government is the cause of their economic suffering, while also introducing the idea of paragraph 4 that Zimbabweans are unable to rebel against their government because they are being dictated. I also learned to cite a website using MLA format, and as you can see, the title of the article goes first in quotation marks, followed by the main website underlined, the source it was founded, the date it was accessed, and the URL. My anti-propaganda and political cartoons show that I'm able to analyze media and not fall for false pretenses, while my cultural universal essay shows that I'm able to properly format a research essay to be effective and well written. In engineering, we did topics that included both integrated math and physics, one of which is the roller coaster project that included the topics of potential and kinetic energy. An object that has the most potential energy is known as energy that is stored and held at a height. This means that the marble had the most potential energy when it was suspended above the roller coaster before it was released. The formula for potential energy is mass, which is measured in kilograms, multiplied by the acceleration due to gravity, which is 9.8 meters per second, multiplied by the height of the object, which is measured in meters. As the marble moved along, the roller coaster lost potential energy. However, this lost energy actually transferred into kinetic energy. The kinetic energy of an object is known as energy of motion. This means that when an object is moving, it is capable of transferring energy or doing work. The marble had the most kinetic energy right when it was going to hit the bottom. when all the potential energy had transferred. The formula for kinetic energy is half the mass times the velocity, which is measured in meters per second, half the mass times the velocity squared. By using these formulas, I was able to find the velocity of the marble at different points on the roller coaster. For example, on point 6, on my ideal conservation of energy worksheet, I first found the potential energy, and then using the law of conservation of energy, found the kinetic energy. The law of conservation of energy formula is potential energy plus kinetic energy initial is equal to potential energy plus kinetic energy final. This means that the total amount of energy that the marble began with should be equal to the total amount of energy it ends with. After I found the law of conservation of energy also states that energy cannot be created or destroyed, but can only be transferred from one form to another. Once I found the kinetic energy, I was then able to put it into the formula, the square root of kinetic energy divided by the mass times the velocity, times the mass times the 0.5, and found the velocity. For exhibition night, we were to create textbook entries that went into further detail. Another topic we learned was how Olympic sports and physics went hand in hand. For my Olympic sport, it was shot put. Before the athlete even throws the ball out of his hand, the first law takes place. The first law, which is that an object at rest will remain at rest unless acted upon by an external force. Likewise, that an object in motion will remain in motion unless acted upon by an outside force. So, in this example, the object at rest would be the shot put, and the external force would be the athlete because he is exerting the force to move the object. Depending on how much force is added, the ball will accelerate. More force, more acceleration. This can be expressed in the formula. Force, which is measured in newtons, is equal to mass, measured in kilograms, times acceleration, which is measured in meters per second squared. As the ball is flying, it has momentum. It loses momentum when its velocity starts to decrease, since it starts to change in direction. The formula for momentum is P, which is momentum, is equal to the mass, measured in kilograms, multiplied by the velocity, which is measured in meters per second. As soon as the ball hits the ground, the third law takes place. The third law, which is that each action has an equal and opposite reaction, means that when the ball hits the ground, the ground is also hitting up against the ball. For exhibition, I will create textbook entries that went into more detail about this topic, and these textbook entries show my deep understanding of this concept. Not only did these projects I have spoken to you about include math and physics, they also included some artistic skills as well, these of which I have been educated in integrated arts and design. One of the most important things we learned about in art was the color theory. The color theory is the study of how colors relate to each other. The way it works is that you can create any color using 3 primary colors, then black, and then white. The 3 primary colors are known as red, yellow, and blue. By adding equal amounts of each primary color, you get secondary colors. The secondary colors are orange, green, and violet. However, if you add unequal amounts of primary colors, you get intermediate colors. 2 examples of intermediate colors are red, violet, and yellow, green. If you add equal amounts of 2 complementary colors, you get a neutral color. If you add white to the neutral color, you get a neutral gray. Neutral grays are usually dull, boring, grayish, or skin tone-ish colors, unlike earth tones, which are warm, friendly, and have an earthy feel. The way you get earth tones is by adding 2 amounts of 2 equal secondary colors. One example would be citron, which is more yellow golden because it uses more yellow in its mixture.